In this video, we're going to review the important points about probability density functions. Let x be a continuous random variable. The sample space is the set of possible values that x can take. For example, if L and U are its upper and lower limits, then x can take on any real value in the interval L to U. The probability density function is that function f of x such that the probability that x lies in the interval a to b, i.e. the probability that x is greater than a but less than b, is given by the integral of f of x with respect to x between the limits a and b. A valid probability density function must have the following two properties. First of all, the value of f of x must be greater than or equal to 0 for all values of x that lie within the range of possible values, i.e. between the upper and lower limits L and U. Secondly, the integral of f of x between L and U must equal 1. For example, is 1 over x squared a valid probability density function for the sample space 1 to infinity? First of all, 1 over x squared is definitely positive for all values of x in that interval. And secondly, if we integrate 1 over x squared between the limits 1 and infinity, we get minus 1 over x, again with the limits 1 and infinity. And if we evaluate that integral between those limits, we get the value 1. Therefore, this function has the necessary properties to act as a probability density function. Finally, let's consider an application. If the probability density function of the random variable x takes this form, 1 over x squared on the interval 1 to infinity, what is the probability that x lies in the interval 2 to 4? In order to do this, we need to integrate the function 1 over x squared between the limits 2 and 4. So integrating 1 over x squared, the indefinite integral is minus 1 over x, and if we evaluate that at the upper and lower limits, we get that's equal to minus 1/4 minus a half, or a half minus a quarter, which is equal to a quarter, or 0.25. To illustrate this, we draw the probability density function here, and we see the probability density function is definitely positive for all values of x, and the probability that we're calculating here is given by the shaded area, or the area under the curve between the lower limit 2 and the upper limit 4.